4 years. For 4 straight years, the sun has not had a single completely blank day. Sunspots, flares, explosions, constant magnetic chaos. And now? Nothing. This week, the sun went completely smooth. No dark spots, no active regions, just a glowing, unblemished sphere 150 million kilometers away. The first spotless days since 2022. That might sound small. It's not. Sunspots are cracks in the sun's magnetic field. When they disappear, it means something deeper is changing inside the star itself. Is solar cycle 25 already winding down? Are we heading towards solar minimum earlier than expected? Or is this just a temporary pause before the sun roars back to life? Because here's the thing. During the last solar minimum, we saw more than 700 spotless days. Could this be the beginning of that shift? Today, we're looking at what a blank sun really means, and why this quiet moment might be the first sign of a much bigger transition. Let's take a closer look. So what actually causes a sunspot? It starts deep inside the sun. The sun isn't solid. It's a massive sphere of superheated plasma, constantly moving, constantly churning. As that plasma rotates, it twists and tangles magnetic field lines beneath the surface. When those magnetic fields punch through the photosphere, they block some of the heat rising from below. That cooler region appears darker. That's a sunspot. Now here's the key part. Sunspots are not random. They rise and fall in a rhythm we call the 11-year solar cycle. At solar maximum, the magnetic field is chaotic, twisted, strong. Sunspots can cover huge areas of the solar disk. At solar minimum, the magnetic field relaxes. Fewer eruptions, fewer spots. Sometimes, none at all. Between 2018 and 2020, during the last minimum, the sun racked up more than 700 spotless days. Entire months passed without a single mark. So when we suddenly see blank days again in 2026, it tells us something important. Solar cycle 25 may be past its peak. Not finished, not collapsing, but slowly easing downward. And this shift matters, because sunspots are tied directly to solar flares and coronal mass ejections. Fewer sunspots usually means quieter space weather, less risk to satellites, less geomagnetic disturbance on Earth, calmer auroras. But here's the twist. Solar transitions aren't smooth. The sun can go quiet for a few days and then erupt again without warning. So the real question isn't whether sunspots will return. They will. The real question is whether we're watching the early steps into the next solar minimum. Take a look at your screen. On the left is NASA's Solar Dynamics Observatory, a spacecraft orbiting Earth and monitoring the sun continuously. This is high-resolution space-based data. No sunspots, no dark regions, nothing disrupting the surface. Now look at the right. This image was captured from the ground in Australia using a small sea-star telescope with a proper solar filter. Different equipment, different location, different vantage point. And yet the result is exactly the same. A completely smooth solar disk. When space-based observations and ground-based imaging agree like this, it's not a processing artifact. It's not a camera issue. It's not atmospheric distortion. It's confirmation. At this moment, the sun is spotless. So now the question becomes, is this just a brief lull in activity, or are we seeing the early shift toward a quieter phase of solar cycle 25? The sun has gone silent before. It always comes back. But moments like this are rare. A completely blank solar disk, after 4 years of constant activity. Maybe this is just a short pause. Or maybe we're witnessing the first quiet steps into the next solar minimum. What do you think? Is this temporary or the beginning of a bigger transition? Let me know your thoughts in the comments. If you enjoy real-time space updates and deep dives into what's happening above us, subscribe and stay with me. Because the sun may look calm right now, but it's never truly predictable. And we'll be watching.